Hi everyone, I'm Felipe Zurita. I'm the guide and the producer today, and we will guide in your virtual experience to Observatory La Silla from European Southern Observatory of ESO. Today I'm alone because I have a little troubles with my partner, so sorry for that. But today we guide around the first of the ESO Observatory, La Silla, more more beautiful, the first beautiful observatory in Chile. Today is in English. The next week is in Spanish to Paranal. So so they have 16 viewers. Hi everyone. Um, from Amsterdam. Hi from Chile. Um, in the next hour, we will travel to the region of Coquimbo in the northern Chile. We will virtually visit ESO La Silla Observatory at 2,400 meters above sea level. We invite you to start thinking about your question. I imagine you already have some ones. From now on, you can write your question or comment in a section, especially in the section in the chat box. So let's start the tour. Wait me a moment. Uh, the first, the ESO is a European organization for astronomical research in the southern hemisphere. It's an intergovernmental organization with 16 member states, along with the host state in Chile, and with a new one, Australian, as a strategic partner. This is very important because the Chile is the only the host is not part of ESO, but is a middle part, middle because the observatory is in Chile. In Chile, have a different observatories. We have aquí observatory facilities in the first. I will start in the northern part of Chile. In the north part, we have Paranal with the BLT, the Very Large Telescope, the greater one telescope in the world, with four telescope of 8 meters of mirror, big machines to look the stars with interferometry mode. In the side of the BLT, we have the base T and the Vista. The Vista is a particular telescope work in the Paranal mountain. And soon we will have the CTA. The CTA is a Cherenkov telescope array. This is to only to see the powerful energy in the sky. I talk about the ray gams, and in the next mountain near of Antofagasta in the northern Chile, near to the BLT, we have the ELT, the Extremely Large Telescope, under in construction now. This is this will be the greatest one telescope in the world on history from now. The telescope will have a 40 around approx 40 meters of diameter of only mirror. Imagine how big is this. And in the same part of the regions of the Atacama Desert and around of 5,000 meters of height, we have in the plane of Shagnator. In Shagnator, we have Alma and Apex. Alma is the greatest radio telescope in the world. Around 66 telescope working together to see the the deep universe of the or weak stars or galaxies are for method of the radio detection of the signals. And Apex is the individual telescope radio telescope from working here. But today we will visit La Silla. La Silla in the fourth region of the Coquimbo. Is the first telescope, is the first observatory in Chile of ESO. So we'll start to move to here. So let me show you a video to start in outside of the planet. We'll start in Europe, in near of Germany. The Germans have the principal building of the operating all ESO's management. So we across the Atlantic Sea. The principal reason of the principal reason of a ESO Boyle telescope or observatories in Chile is to see the southern hemisphere, the southern sky. So with that reason is uh, the reason we have a different sky. In the southern have a Milky Way around. You can see and other kinds of the constellations. So we will move to Desert of Atacama. Here is the South America, and we'll start the move to Observatory La Silla. We are located in the Atacama Desert on the head of the Andes Mountain. So we start to move over La Silla. Let me here. This is specifically a little more than 1,600 kilometers north of Santiago de Chile. This is the capital. Around of 1,500 kilometers north of La Serena. The city used a logistic base to the observatory. You will see two things in the screen. You will have La Silla have around 19 telescope different for different countries and different used to work and see different part of the different part of the universe. Take a look at the shape of the mountain. There remains something you can see very well, but let me do plan out and let me here. Wait a moment. Sorry, here. We are in the La Silla mountain. Take a look of the shape. This is the shape of this mountain. Do remind you of something? Maybe a horse saddle? This is precisely what gives the mountain name, within lots of imagination. This mountain name. Finally, the observatory called the La Silla Observatory for the shape of this part of the mountain is a horse saddle of this telescope to this telescope in the form. Over the years, this observatory has become the perfect armchair for studying the universe. At the beginning of the 16th, this observatory founding in the 1969 year, and some of the telescopes served in the imaging are out of service. But actually, this observatory actually maintain the old telescope to renovate on the new telescope. We have a reading from Bosnia and Herzegovina. Hi, everyone from Chile. Thank you for your greetings. And currently, here are 19 still operative from now, from different countries, Holland, Poland, Germany, French. Uh, the other telescopes, several which are robotic, belong, although the other institution to ISO will provide its quality on the necessary support. Today, in particular, we visit two flagship telescopes. We give a real astronomy study class. The first one You can see it in the image. The fish located in the top of the mountain and framing the light blue circle. This is this is the ESO 3.6-meter telescope, a giant planet hunter. And the second we visit today is one of the hidden between two circles. You can see very well because I can zoom more. This is the NTT. The NTT was a pioneer. It is incorporated in the technology advance to now have allowed to construction a giant telescope. This is the father of BLT, and this is will be the father of the LT. We will take a step to side to see the better. So let me. Uh, so we inside the 3.6 here. Here. The 3.6 started operating in the 1977 as a challenge for engineering and representing the green mission of ESO as organization. From the beginning, Europa the ESO joining force with the various countries to construct an optical telescope in the first middle category. This is the big one. You can look that guy. This is a little compared with the big machine have in the side. This this person is around 1.8 meters of height, but this telescope have around of 50 meters of height, and the dome is more bigger than the telescope. So this building is around eighth floor, around 8 and 9 floor of meters of height, floors of height. Sorry, my English, I forgot some words. Which is the largest and most advanced category to exist at the time. Why such a large telescope need? In astronomy, we analyze our objects to study through the light. This is the travel light. First, we have a window to the when in the night open the window, the light enter and receive in the principal mirror. This is the principal mirror. This is the 3.6. This part is the 3.6-meter mirror. A mirror you have in the bathroom or in your house, but this particular mirror have a 1 meter of height of large and 3.6 meter of diameter around. This is a big piece of of the mirror of ceramic in particular, and around uh, 12 tons of mass. This is too heavy to move. To more light we collect for big mirrors, more light you can collect. Tomorrow we will note about them. In this case, the large of the mirror, the greater the amount of light we will have, and consequently, the more information available available to be analyzed. We will see the fainter object and distinct smaller details. However, an astronomer mirror is not like any other mirrors. Since is the shape and the surface must have a perfect and the level of fraction of millimeters. To achieve this, in the 1970, an extremely thick mirror was manufactured. 53 centimeters thick of average is a little average of mistake. Nothing to worry about. But this also means that the mirror is extremely heavy. I say this is a 12 tons. If we want to control larger telescope, we need to find other solutions, other ways to construct this big in a small place. How is this step taken? We will see later in the entity, but this is a little the first one great telescope building for himself. So we will move to outside, like here. This is the outside of La Silla. We enter to 3.6, the old way of building the telescope. So we will move uh, to this part and the new way to building the telescope. If you ask for visit this in person, you can visit free in a ISO point or org. In the page of ISO point org, you can reserve the visit to visit this beautiful telescope. So I invite you to inscribe and visit our country to visit this beautiful telescope of ISO. Every every Saturday and in the winter every Sunday too, you can visit this 3.6 and the entity in person. You can inside. You can move here. Let me show you again. You can move around here. You can take a photos and ask question about astronomy, whatever you want when you come. So the other telescope you can visit is the entity too. So now it's a virtual, but inside. Let me here. So the entity was inaugurated in 1989 and has a small and very compact dome, a octagonal design. This particular design here, this is a square or level or a little octagonal design, is as if had uh, an octagonal design and a system of flaps. They represent in this day evolutionary leaps in the construction of the telescope. This is permitting the housing of instrument in a smaller, lighter structure and also for more efficient airflow to the inside. In this particular telescope, you don't have a little window to see the sky. You have the entire top of the building to see. You see the galaxy or the creations. These represent in today evolutionary leaves is gone the more classic and voluminous domes, such as 3.6. In fact, the flap allow air to flow without obstacle. The wind flow here w- versus the telescope, and let me put in the other side here. Here's the other side of the telescope, and the air flow to the other side. In this case, the building is practically attached to the telescope, and we start in front of it. We will look approximately this size. This is smaller. This telescope mounting is also completely different. Here's the entire building spin around 360 degrees. Is moved around of own point. So the telescope only moved to up and down, and the entire building is moved across the circle. You can see the my mirror. Let me show you the mirror here. This is the my mirror, or in the other side. Can I show better? This is a little part of the mirror here. You can see the my mirror in the colored round structure. This dig is the mirror, and we can see the reflects some light. Do you remember 53 mirror of the 3.6? Well, the mirror of the entity has almost the same, or a little same diameter of the 3.6, around 3.58 meters to be precise. But this is insignificantly thinner. The mirror is only is only 44 centimeters thick. These small lighters around 6 tons. To maintain the perfect shape of this mirror of the telescope, meanwhile the telescope moves, there is a system of actuators. This is the second principal discover or manufacturing of ESO to perfectioning the observating from direct the telescope. It's a piston below the mirror. The system is enclosed inside the box to use it used below the mirror. Here's this part below. The system is enclosed inside the box. This system is a computer controller and is Skype active optics. The optics was developed to ISO and represent the significantly technological advance in the construction of the next generation of the telescope in the 10-meter category. Today, active optics is used on all the large modern telescope, not only from ISO, for other telescopes, from Las Campanas, or other 4 meters telescope use now the optics from the shape of the mirror. Actually, in ISO, the BLT used this technology. From that reason, the entity is the father of the BLT, and the ALT, the extremely large telescope, have to. The secondary mirror here, let me show you again. He's above in hertz, like in the 3.6. This mirror take the light from the my mirror. The my mirror take all the light from the sky and conce- con- and move to the secondary by mirror director to the another mirror to finally transport. So the secondary send all the information a first mirror. This is a plane mirror to move the light to the one side or to the other side to wait the the instrument. Sorry. In this case, we cannot see them either, since there is an adjacent room in a cool room, cool room alongside the telescope. So, if you have some question or you can leave your greeting. Sorry for my weak English, but I'm better in the next time. So, one question usually you have is, where is the astronomers? Where's the people move these big machines? Um, the people work. Let me show you a video. The people work in a control room. In this time lapse, you have two parts of the one control room in the mountain of La Silla. In the left part, you have a entity control room, and the right part, you have a 3.6 control room. This is in the same room, but separately in sections. And the third section is for 2.2 telescope from Germany, for the Max Planck Institute. In particular, you have two kind of people working here. The first one is a darker one, the darker clothes that is the operators, the TOs. The operators is encouraged to move the telescope, uh, uh, maintain of the telescope, or all above the telescope to move or working together the astronomer. And in the color in the color clothes, this is directly the visits astronomers. The visit astronomer constantly change because the astronomer only have a few nights per years for our investigation. Here's come to La Silla and work together the operating and telling what need to see in the sky, and in the night see the sky, take information, and bring to the lab. Usually in Chile, in particular, is from universities, another country for science organizations, or two universities for investigate your information. The astronomers have 1 year to investigate all all information recopilated from these visits. But the visit will need to reserve with 1 year's pass of reservation. It's a it's a little competition from night in the years. So now I will show you the principal discover from ESO and these magic parts in the control rooms in astronomer. We have a principal discover. So we have a top 10 to show you all the principal and greatest discoveries from ESO. So let's start.
Observations with ESO telescopes have led to many breakthroughs in astronomy and, over the years, have been responsible for some truly remarkable findings. Here is our list of ESO's top 10 astronomical discoveries so far. Astronomers using ESO's Very Large Telescope have discovered by far the brightest galaxy yet found in the early universe, and found strong evidence that examples of the first generation of stars lurk within it, stars that were previously only theoretical. These massive, brilliant objects were the creators of the first heavy elements in history, elements that are necessary to forge the stars we see around us today, the planets that orbit them, and life as we know it. ESO telescopes have provided definitive proof that long gamma-ray bursts are linked with the climatic explosions of massive stars, therefore solving an enduring mystery. A telescope at La Silla was also able to observe the visible light from a short gamma-ray burst for the first time, showing that this family of objects most likely originates from colliding neutron stars. Astronomers using ESO's HARPS instrument in 2010 discovered a planetary system containing at least 5 planets orbiting the Sun-like star HD 10180. They also found evidence that 2 other planets may be present, one of which, if confirmed, would be among the lowest mass exoplanets ever found. Newer observations and reanalysis of the data suggest that there could be even more planets around this star. ESO's Very Large Telescope was used to detect carbon monoxide molecules in a remote galaxy, seen as it was 11 billion years ago, a feat that had remained elusive for 25 years. This allowed astronomers to obtain the most precise measurement of the cosmic temperature at such a remote epoch, and it matched the temperature predicted by the Big Bang theory. The atmosphere around a super-Earth exoplanet was analysed for the first time using the VLT. The planet, which is known as GJ1214b, was studied as it passed in front of its parent star, and some of the starlight filtered through the planet's atmosphere. The atmosphere was found to be either mostly water in the form of steam or dominated by thick clouds or haze. Using ESO's VLT, astronomers measured the age of the oldest star known in the Milky Way. At 13.2 billion years old, the star was born in the earliest era of star formation in the universe. Uranium was also detected in a Milky Way star and used as an independent estimate of the age of the galaxy. The VLT obtained the first ever image of a planet outside our solar system. The planet, which has a mass about 5 times that of Jupiter, orbits a failed star, a brown dwarf, at a distance of 55 times the average distance between the Earth and the Sun. In 2014, ALMA, the Atacama Large Millimeter Submillimeter Array, revealed remarkable details of a solar system that is forming. The images of HL Tauri were the sharpest ever made at sub-millimeter wavelengths. They show how forming planets are vacuuming up dust and gas in a protoplanetary disk. One of ESO's proudest moments came when 2 independent research teams, including ESO staff, arrived at a truly revolutionary finding: that the cosmos is not only expanding, but that it is doing so at an increasing rate. The findings of the separate teams were based on observations of exploding stars, or supernovae, including measurements made from ESO's telescopes at La Silla and Paranal. This discovery was rewarded with the 2011 Nobel Prize in Physics. And finally, several of ESO's flagship telescopes were used in a 20-year study to obtain the most detailed view ever of the surroundings of the monster lurking at the heart of our galaxy, a supermassive black hole. Astronomy is always moving forwards, and ESO's top 10 scientific discoveries are not set in stone. Observations.
I hope to enjoy this video. I My favorite is the part 1 of the greater black hole in the center of the universe, in the I two in the 2019 in 2019 we have the ESO with the others organization have a Horizon 11 telescope to take a photo of the first black hole in the Messier. Let me think, in the Messier 31, I think. So this is the first picture of the black hole detecting and see. This is not only theoretical, the theoretical part of the universe. And you can see this is a night already. There is no moon. Nope, no moon. This is the beautiful night, which allows you to contemplate the heaven in all its splendor. On the bottom left side of the entity, let me zoom it, there is a easily recognizable constellation. Can anybody identify? You can identify? Oh, hi Peter. The entity is still being used for scientific purpose. Yes, the entity is still being used. This is the optical and near infrared use for see the galaxies. This is not discontinued. On the other way, the 3.6 2 is still functionally finding the exoplanet. The 3.6 principal function is for finding exoplanets too. Thanks for your question. You can leave your question, and meanwhile, in the tour, I can read and answer you. So this part of the sky in the side, this is the Orion, the Great Hunter. You can see this part. In the Southern America, these 3 stars, also known as the Tres Marias, and in the right of this part of the Orion Belt, you have a Betelgeuse, the green red one, and in the left, you can have a Rigel. Probably that after a long journey in the sky, Orion is about to lie on a western horizon. Based on its position in the sky, we're either in summer or autumn, maybe. The hunter and the accompanying great dwarf in the Canis Majoris, here are Sirius, we have followed a very special path to the sky, the Milky Way. This is the principal reason the ESO founding in Chile this observatory. Our galaxy, the Milky Way is our galaxy. Actually, our galaxy is a huge spiral-shaped flattened disk. You can see, but we see is a luminous band in the sky because of our perspective, since we are inside the disk. Or the other way, you can see a circle in the sky. This consists of some of 200 billion stars and immense clouds of interstellar gas. This is an interstellar gas, and this part is an interstellar dust. You see the latter in the form of the dark clouds shaking across the luminous bands. The red clouds are hydrogen, the simplest and most abundant element of the universe, from which the stars are formed. By looking through the Milky Way, we find two strange objects similar to clouds. In fact, these are the large and small Magellanic clouds. These are southern objects in the sky, the small Magellanic, or nubes de Magallanes. Our closest neighboring galaxy at the same time are smaller than our Milky Way. They get their name from the first written record of their observation, dating back to the time of circumnavigation of the globe, by Hernando de Magallanes, clearly. At the time, nobody knew what a galaxy was. In that times, you see a beautiful shiny cloud, but this is a galaxy you can see with your eyes in the night, a very dark night. You can see very well with your eyes. Imagine with a telescope. Today we know the galaxy are the system hosting 10 billion of the stars, and that becomes their shape. This one of the classified as irregular. For that reason, they don't have a black hole or have a particular shape, so it is classified as irregular. These typical objects are in the southern sky, I tell you. Also indicate the position of the south celestial pole. We have two methods to have to indicate or localize the southern. In the southern hemisphere we don't have another star in with the collection and in is with the constellation of the Southern Cross. Let me show you the Southern Cross. This and these four stars making a cross, be extending the major axis about 3.6 times in direction of the large. Here's a arrow. You can see point to the down. You can extend 3.5 times this large, one, two, three, and the middle. So we start to this part correspond to a triangle with the Magellanic Cloud. Let me see. This is a triangle of Magellanic Cloud. Sorry for my inexacting pointing from. This is the one, two, three, and this part is the southern part of the hemisphere, southern celestial hemisphere. But coincidentally, this is the southern direction. So you can find the southern direction when in the using the stars in the southern. So if we continue to explore our Milky Way, T will stay up back on the 3.6. In the back of the 3.6, behind this, the center of galaxy rise majestically, recognizably of the bowling shape and the prominent dark clouds surrounding it. You can look at the prominent clouds, the biggest dark clouds surrounding it. It can contain in this part, a huge black hole, the black hole of the Milky Way. On the left side, you can see a colorful nebula and the dark filament to surround the red supergiant star Antares. This is Antares, which is the brightest star in the constellation of Scorpius. The animal that, according of the mythology, will put in the end of Orion life, being the same god of Olympus who will locate in the polar opposite on the celestial sphere. You can see the Scorpion, and in the other side of the galaxy, we have Orion. Together, continuing moves. If we now look at this region, let me show you. In this region on the sky, with the eye of the Latine community of the mountain of Andes, we will not look the bright star, but the shape of impressive dark holes most notably have at the shape of a llama. Yes, the Moyes, the Dieguitas, all the old communities of astronomy, you can find this a llama. This is foot, the neck, the head, and the eyes, the principal eyes, is Alpha Centauri. In fact, Tig is actually three stars, but you see that's one the closest to our sun. You may ask about the fascinating color of this picture, right? So let me move to 3.6 outside of the 3.6. This is outside of the 6, and this is view of La Silla. You can see the La Silla dark sky and fascinating color of the picture. There is real, but then we see the sky in the black and white because our color receptors, the cone of our eyes, cannot perceive very low light intensities, just as those of the night sky, such as the nose of the night sky. However, in a camera, we can leave the shutter open and use a long exposure time to collect light, and thus, with a careful processing work, we can decipher their colors. Now it's time to move, to relax, and I will move to La Silla, to the hotel of La Silla. But I will move in the while we prepare to the last part of the tour, we invite you appreciate these views of the Milky Way. If you are in the northern hemisphere, you need to visit the southern hemisphere. Not only Chile, you can visit South America for for beauties. This particular sky. This is a beautiful one. One time, a French tell me in a special visit, tell me, "Wow, the northern sky is boring." In Chile, called fome, but this is the same. It's boring. I'm asking why. Why is boring? Because we have different stars, different constellations, but I don't have the view of the all Milky Way. I lots of stars. So I think, wow, this this is a big difference. You can confirm someone. This is a big difference. I don't know, but I hope soon visit the northern part of the planet, some European sky. But I don't think the any part is boring. We have a different object to see, different object object or different ways to see the sky or the universe. So we will move around the little telescope, the 1.2, the robotic telescope. So we will move to the hotel. So with the sky of the Milky Way, the center of the Milky Way, we have in the hotel. In this place, where astronomers, operators, and superstars of the observatory take a rest while time passes until their shift observer start again. So this is the principal photographer from this visit in particular. So thank for all these beautiful viewings. Um, if you have some question, if you have some whatever you want to ask about the astronomy, the galaxy, or the visit, I want to remind you that all these visits are available in the ESO webpage, the ESO.org. We also have a survey you can send your comment about the tours or for reserve the visit, presential visits. I hope to enjoy this. Sorry for my English, but I am I hope I'm better in the next time. So thank you for my watching, and in the next week we have a parallel, the most technological observatory. Bundesliga is was the first. This is the father, and the other is the son. I say me. So I hope you enjoy, and thank for viewing this, and goodbye from today. Bye bye.